You know that moment. You start your dev server and the terminal says port 3000 is already in use. So you try 3001. Also in use. You open a new tab, run lsof, pipe it through grep, squint at the output, try to figure out which PID belongs to which project, and eventually just kill -9 everything and hope for the best. Today, I want to show you a tool that makes this entire ritual unnecessary. It is called Port Whisperer, and it turns those cryptic loft dumps into a clean, color-coded dashboard of everything running on your machine. By the end of this video, you will know exactly what Port Whisperer does, how it works under the hood, who it is built for, and how to get it running in about 10 seconds. Let's get into it. So what is Port Whisperer? At its core, it is a Node.js command line tool that answers one question: what is listening on my ports right now? You install it globally with npm install -g port whisperer, and then you just type ports. One word, and what you get back is a beautifully formatted table showing every active port, the process name, the PID, the project directory, the detected framework, how long it has been running, and whether the process is healthy, orphaned, or a zombie. That last part is important. Port Whisperer does not just list ports. It actually diagnoses process health. A healthy process is one that is running normally with a proper parent. An orphaned process is a dev runtime whose parent PID is 1, meaning its original parent died but it kept running. And a zombie is a process that has exited but has not been properly cleaned up by the operating system. These show up color-coded: green for healthy, yellow for orphaned, red for zombie. At a glance, you can tell something is wrong. Now let me walk you through the commands, because there are several and each one is genuinely useful. The default command, just typing ports with no arguments, shows you only dev-related ports. It filters out system applications like Spotify, Raycast, Slack, Chrome, and dozens of others. The tool maintains a curated list of known system apps and only shows you things like Node, Python, Ruby, Java, Go, Docker containers, and other developer runtimes. If you want to see absolutely everything, you add the --all flag. If you want details about a specific port, you type ports followed by the port number. Say ports 3000. This switches to a detailed view that shows you the full process tree, the repository path on disk, the current Git branch, memory usage, and when the process started. It even gives you an interactive prompt asking if you want to kill the process right there. You can also use the alias wasim-port 3000, which does the same thing. Then there is ports kill. This is the surgical option. You can kill by port number, by PID, or even pass multiple targets at once. So ports kill 3000, 5173, 8080 will resolve each of those ports to their respective processes and terminate them. By default, it sends sigterm, which gives the process a chance to clean up gracefully. If something refuses to die, you add -f for force, which sends sigkill instead. The tool is smart about resolving targets too. If the number you pass is in the valid port range of 1 to 65535, it first checks if something is listening on that port. If not, it falls back to treating it as a PID, so you do not need to think about whether you are passing a port or a process ID. There is also ports PS, which is like a developer-focused version of PSOS. Instead of showing you every process on the system, it filters down to dev runtimes and shows CPU percentage, memory, framework, uptime, and a human-readable description of what each process is doing. Docker processes get collapsed into a single summary row that shows the total count, combined CPU, and combined memory. This keeps the output clean instead of flooding you with 14 separate Docker subprocesses. Ports clean is for housekeeping. It scans all listening ports, identified any that are orphaned or zombified, lists them with their details, and asks you to confirm before killing them. It only targets dev runtimes, so it will not accidentally terminate your desktop applications. This is the command you run when you have been developing all day and your machine feels sluggish from accumulated abandoned dev servers. And finally, Ports Watch gives you real-time monitoring. It polls every 2 seconds and prints a timestamp log whenever a port starts or stops listening. You see a green up arrow with the word new when something starts and a red down arrow with closed when something stops. This is useful if you are debugging a service that keeps crashing and restarting, or if you just want to keep an eye on your port landscape while you work. Now let me get into the part I find most interesting, which is how this actually works under the hood. The entire tool is only 3 source files. Index.js handles argument parsing and command routing. Scanner.js does all the system introspection, and display.js handles the terminal rendering with chalk and clab table 3. The performance story is surprisingly good. For the default table view, the tool makes exactly 3 shell calls. First, lsof-i tcp-s tcp::listen, which finds every process listening on a TCP port. Second, a single batched PIDs process details for all discovered PIDs at once, including the parent PID, process state, resident memory, start time, and full command line. Third, a single batched lsof-dcqd call that resolves the working directory of each process. If any of those processes are Docker, it makes one additional Docker PS call to map host ports to container names and images. This batching approach is the key architectural decision. A naive implementation might make 6 cell calls per process, 1 for PS, 1 for tupsess, 1 for the working directory, 1 for the parent process, and so on. With 10 ports open, that would be 60 shell calls. Port Whisperer does it in 3 or 4, regardless of how many ports are active. The result is about 200 milliseconds of execution time, which means it feels instant. The framework detection system works at 3 levels, and this layering is clever. The first level reads the package.json file in the detected project root directory. It checks both dependencies and dev dependencies for framework-specific packages. If it finds next in your dependencies, it labels the project as next.js. If it finds Angular/core, it is Angular core. It is Angular Crow. It covers about 20 frameworks this way, including Next, Nux, SvelteKit, Remix, Astro, Vite, Express, Fastify, Hono, Nest.js, Django, Rails, and more. The second level checks for framework-specific config files. If there's a vite.config.ts in the project root, it is Vite. If there is an angular.json, it is Angular. A cargo.tomlet means Rust. A go.mod means Go. A manage.py means Django. This catches cases where the package.json might not have the framework as a direct dependency. The third level inspects the actual command line of the running process. If the command includes the word next, it is next.js. If it includes uvicorn, it is fast API. This is the fallback for cases where the working directory detection failed or the project does not have a standard manifest file. For Docker containers, specifically, the tool parses the image name. A Postgres image becomes PostgreSQL, Redis becomes Redis, local stack becomes local stack, and so on. It supports about a dozen common infrastructure images out of the box. The project root detection algorithm walks up the directory tree from each process's working directory, looking for marker files like package.json, cargo.toml, go.xml, or build.gradle. It stops after 15 levels to avoid walking all the way to the file system root. This means it correctly identifies project roots even when a dev server's working directory is a nested subdirectory. The orphan detection logic is straightforward but effective. When the tool fetches process info via PS, it checks 2 things. If the process state includes Z, meaning zombie, it gets flagged as zombie status. If the parent PID is 1 and the process name matches a known dev runtime, it gets flagged as orphaned. Parent PID 1 means the process was adopted by the init system after its original parent died, which is a strong signal that a terminal was closed or a script crashed without properly terminating its child processes. Now, who is this for? Port Whisperer is built for developers who run multiple services locally. If you are working on a microservices architecture where you might have a front end on port 3080, a database on 5432, Redis on 6379, and maybe a second front end for an admin panel on 3001, this tool gives you a single command to see all of that at once. Full stack developers, backend engineers running Docker Compose stacks, and anyone who has ever lost track of what is running on their machine will find it useful. It is also valuable for developers who context switch between projects frequently. If you start a dev server in the morning, switch to a different project after lunch, and start another server, you might forget the first one is still running. Port Whisperer's clean command handles exactly this scenario. The dependencies are minimal. The tool only uses 3 npm packages: chalk for terminal callers, table 3 for rendering the ASCII tables, and string width for correctly measuring the display width of strings that include emoji or Unicode characters. Everything else is built on Node's built-in child process module and standard Unix tools like LF and PLs. There is no daemon, no background service, no configuration file. It is a pure command line tool that queries the system on demand. One thing to be aware of is platform support. Right now, Port Whisperer's macOS only. Linux support is listed as planned, and Windows is not planned. The reason is that it relies heavily on sof and the specific output format of macOS's PS command. The regex patterns that parse process information are tuned for macOS output. A Linux port would need to handle different column layouts and potentially use /proc instead of lsof for some operations. Getting started could not be simpler. You run npm install -g port whisperer. That is the full installation. Then you type ports. That is it. If you do not want to install it globally, you can use npx port whisperer to run it directly without installation. The tool requires Node 18 or higher, which is the current LTS baseline, so most developers already have a compatible version installed. There is no configuration step, no init command, no dot file to create. The tool works immediately because it gets all of its information from the operating system itself: your ports, your processes, your project directories, your package.json files. It is all already there. Port Whisperer just reads it and presents it in a way that is actually useful. To wrap up, Port Whisperer solves a small but genuinely annoying problem. It replaces the lsof pipe grep pipe hawk dance with a single command that gives you a complete color-coded picture of your development environment. The implementation is clean. The performance is fast thanks to bash system calls. And the framework detection is surprisingly thorough. If you spend your days running dev servers, this is worth the 10 seconds it takes to install. Check out the project on GitHub. Thanks for watching, and I will see you in the next one.